In this video, we'll take a look at probability tree diagrams, which is another way to visually represent a sample space. They're very useful where more than one event is happening. So our first example is a coin is tossed 4 times, so that means we've got 4 events. And we want to find the probability of there being 2 heads and 2 tails. So we can start off our tree with our first branch being our first event. So we can either have head or tails or head. The chance of flipping either of those is 1/2. We're going to flip it a second time, so we have another branch. If you flipped a tail the first time, you could again flip a tail, or you could flip a head. Same down here. And we're going to keep going because we've got 3 branches. Okay, so this is our third event. Tail, head, and we've got one more branch to do. Tail, head, nice and small up there. Tail, head, tail, head, tail, head, tail, head. Obviously, you can see as the number of events happens, your tree diagram can get a little bit time consuming, but you could still have a visual picture of what's in your head. So each branch of our tree represents the flip of the coin. If you follow along all the branches, you will get all the possible outcomes. So for example, if I follow along on my first branch, T, 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 that outcome would be 4 tails in a row, and I can keep going down my list. Okay, so then I could get tail, 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 head, tail, tail, head, tail, 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 head, head, tail, head, tail, 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 head, tail, head, tail, head, head, tail, tail, head, 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 tail, 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 head, tail, tail, head, head, tail, head, tail, head, tail, head, head. Last branch, head, head, tail, tail, head, head, tail, head, 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 tail, and last but not least, all 4 heads. Now what our question is asking is find the probability of there being 2 heads and 2 tails. So I know, okay, that in order to get 2 heads or 2 tails, my probability is going to be the same no matter which pathway I take. So if I look 2 heads, 2 tails, let's look at this pathway right here. So I'll do that in green. So I would go tail, tail, head, head. So my probability of getting that is going to be 1/2 times 1/2 times 1/2 times 1/2. I also need to multiply by the number of pathways that I have. So here's 1, 2, 3, 4, 5, 6. So I've got 6 pathways, so I'm going to multiply by 6, which is going to give me 6 over 16, which is 3 over 8. So that's the probability of getting 2 heads and 2 tails. You can also find all your outcomes, and then you can count your number of outcomes out of your total number of possibilities. 6 pathways over 16 options also reduces to 3 over 8. So let's take a look at another example where we've got some different probabilities. So the probability that George, a good forward in soccer, scores a goal is 0.3. George takes 3 shots. Assume that the success with each shot is independent from the previous shot, and we've got 3 probabilities to find: 2 goals, no goals, and at least 1. So let's set up our tree diagram here so we can visualize the event. So our two options is that we have a goal or not a goal, G prime. Our probability that George gets a goal is 0.3, which leaves the other branch to be 0.7. Those two branches have to add up to 1. Okay. Our next branch, if he scores 1, they're independent. So he could score another goal or he could not score. And our probabilities are the same again. So same thing, on his second shot, he could score or not score. And then same thing on his first shot, score or not score. Okay, as we're going down, we're just counting all the possibilities and considering each of the possible combinations. Okay. So now that we have all that information, we know that our probabilities are the same all the way through, they're not affected. So we can fill those in too to make it a little bit easier as we go through. 0.3 and 0.7. Okay, so now